Alright guys, so what we're going to look at today is a little bit of applications with some synthetic division. So we're going to look at two different theorems, and we're actually going to look at the theorem written out in words. You don't need to know how to rewrite this, but you just need to understand what it means and what it can help us to do. So the first theorem we're going to look at is called the Remainder Theorem. Basically, what the Remainder Theorem tells us is that if you have a polynomial divided by some binomial, then the remainder of that division is the same thing as if I were to evaluate that function at that point. So what that means for us, it's going to make a little bit more sense in an example. If I want to evaluate this polynomial down here at 3, so p of 3, I can do that like I did in Algebra 1, where I just plug in 3 everywhere there's an x, and I can do all that math to get my answer. It's some pretty big numbers to work with, but I can still find my answer and end up getting -4. What the Remainder Theorem tells us, though, is that there's another way to work this out. What I also could do is use synthetic division with 3 as my number in the box. So if I put 3 in that box, I'll do my coefficients. There's 2, -7, then there's 0x, and then there's 5. And with a synthetic division, I bring down my first number, I multiply by the number in the box, and I add down the column. Multiply by the number in the box, add down the column, multiply, and add. And if you guys look, my remainder is the same thing that I got when I just filled in 3 for x. So what the Remainder Theorem is going to help us to do is actually going to come into play with the next thing we're going to look at, and that is the Factor Theorem. Okay, now the Factor Theorem might come across as a little confusing, but in practice it's actually pretty simple. So what the Factor Theorem says, it says that if C is a 0 of p, so that means some number is a 0 of a polynomial, that if is actually if and only if. It's just a little abbreviation for you. So that's if and only if. So C is a 0 of p if and only if x minus c is a factor. And if and only if statements, what that means is that that statement is true both ways. So not only is C a 0 of p if x minus c is a factor, it also means that if x minus c is a factor, then c is a 0. So it actually has to read true both ways. And you guys have already learned this. It just might not make sense written out. If I know, we'll start the other way. If I know that x plus 2 is a factor of a polynomial, I know -2 has to be a 0. If x minus 3 is a factor, I know 3 has to be a 0. And it works the other way as well, because it is a biconditional statement. If 1 is a 0, x minus 1 has to be a factor. And if -3 is a 0, then x plus 3 has to be a factor. So that's really what the Factor Theorem is kind of helping us figure out. And what we can do is we can use that to help us figure out a few things. And that should not be an equal sign. That should be a minus sign. Okay, so we're going to do this next question. There's actually 2 parts to it. The first part is just simply we need to show that 1 is a 0. And we're going to do that by using the Remainder Theorem. So if 1 is a 0, that means when I plug in 1 for x, I get a value of 0. So that means using the Remainder Theorem, if I do synthetic division with 1 in the box, if I get a remainder of 0, then 1 is a 0. So I'm going to work this out. And I did. I got a remainder of 0. So by doing that work right there and getting a remainder of 0, I just showed that 1 is a 0. Now, using the Factor Theorem, I can do a little bit more with this. According to the Factor Theorem, if 1 is a 0, that means that x minus 1 has to be a factor. Then it's actually pretty simple to find my other factors, because if x minus 1 is divided out, which is essentially what we just did with that synthetic division, the polynomial I'm left with is already written down. So that means that the rest of my equation is x squared plus x minus 6. So this has actually helped us to factor. Now the directions do say to factor completely, so I'm not quite done yet. I actually can factor this blue part even farther. So this blue part factors even farther to x plus 3 and x minus 2. And that x minus 1 is still there, so my final written out factored form is right here. Now what we're going to do tomorrow is going to be very similar. It's just going to be a little bit more difficult to start, because what we're going to do instead is, it's not going to tell you the number to start off with, but it's going to be the same kind of process. And that's it.